Okay, today I'm going to do a walkthrough. Maybe I key it down at the end on a Tram D201A. D201As were 40 channel, D201s were 23 channel. As far as I know, there were only two tube SSB 40 channel CB radios made. One was the Tram D201A and the other one was the Browning Golden Eagle Mark 4 or 4A. 4A is just an improvement over the 4. Those were the only 40 channel all tube SSB radios made. I guess they made the DAC-10, but the DAC-10 is just a transistor radio with a tube final, I believe, or it might have an audio and a tube final. But anyway, we dealing with the Tram D201A. Again, 40 channel SSB radio. I think the most complicated tube CB radio ever made. Probably one of the most expensive tube CB radios ever made. And I think just performance wise, not dependability, but the performance wise, I think the best CB all around CB radio ever made. The transmit is phenomenal. You'd have to go real esoteric to beat the transmit on the Tram D201 or a D201A, and the receive is great. It's on par with the best. So, you know, to me, a working D201, D201A, the receive, you know, is probably a 9 out of 10. You know, compared to anything else, and the transmit is probably a 10 or maybe even a 12 out of 10, you know, compared to anything else. And you put that together, to me, the D201 series is the best performing CB radio made. But one of the problems with it, especially the D201As or the D201 series, they went circuit board, and then on the D201As with the 40 channel, they use all crystals. They used a lot of crystals, a crystal bank, and they used that on a board. That's all the crystal. Well, not all of them. That's the synthesizer crystal board with the crystals that they used to make the 40 AM, and they use some more crystals for the SSB, you know, mixed together to make the frequencies in a D201A, and then it's got a couple more, like you see a couple crystals mixed with that for the transmit, and there's another one over here for the receive. Come on, camera. I see it with my eyes, but I don't see it with the camera. Where are you? There you are. Right next to that, to the left of the tube on the right. Another crystal for the receive. So it's got a bunch of crystals in it. And the two problems this radio are known and maligned for are, one, you got tubes on a circuit board. You know, that big bad 6L6 runs really hot. You got a circuit board next to it. You got tubes mounting the circuit board. You got a lot of tubes over there in the circuit board. You got the final tubes on the steel chassis, which is kind of interesting. But and another thing, this versus the Browning, this is all in one box. So it's a lot of components, a lot of parts, a lot of heat, because you got a lot of tubes in one box. So it runs very hot. And between the heat and the circuit boards, you know, over time, you're going to have problems. One of the quick and easy fixes for that is to put a fan on the thing. I like bolting the fan to the back using the holes there, and then you don't even have to drill and deface the radio. And if you decide you want the fan, just unbolt it, and you know, there it's like you never you know, modded the radio at all. If you want, you know, two fans, put another one on that side. So that's a quick and easy fix. But the other problem besides heat and circuit boards with this radio, they got all them crystals, you know, for 40 channels, AM and SSB. For, I think for USB, it uses, you know, a different set of crystals here, and that's is basically two sets, one for AM, one for USB here, and then it mixes with this other 5 crystals down here that provide 20 megahertz out, and then for receive, it mixes with, I think, that crystal. And then for transmit, it mixes with one of these, one for AM, one for USB. So it's a lot of crystals going on. But the problem was to switch all these crystals, you know, through 40 channels and AM and SSB, different ones. This is the crystal selector switch. Inside that black box is just a bunch of rotary wheels that perform the switching. So when you turn the channel knob, which I'm turning back here, you can see the dial moving. It turns and makes and breaks a bunch of switches here to connect one of these and one of those. Or not connect, but activate one of these and one of those that, you know, mix together to perform your crystal function and to make your crystal output. And while I'm on it, all this board does with all the crystals is provide 20 megahertz out. You know, like, I'm not going to use the right frequencies like 20.01 for channel 1, you know, 20.20 for channel 20, 20.40 megahertz for channel 40. That's not correct, but I was just giving you an example of how that works. All that, all the crystal board is powered by the low voltage board here. All that to get 20 megahertz out. In a modern radio, a PLL will do all that and more. So that's the problem they had. They got all these crystals, a big cost. Crystals, you know, during the CB boom got expensive. And that's one of the reasons everybody went to PLL, because of the cost, you know. I think, you know, back in the day, crystals cost $10, $20 a pop, right? So what's this thing got in it? About 30 altogether? It's a lot of money in crystals. It's why Browning, with the Mark IV, went to a PLL, even though PLLs weren't perfected yet. And on the Mark IV, the Browning PLL failed a lot. You know, it just wasn't up to the task because, again, it wasn't perfected. And then they used the perfected one, a newer one, in the 4A. So to me, the 4A is the desirable radio. But anyway, back to the Tram. One of the things I wanted to walk through, I'm not getting technical yet. I'll probably have some up and coming. But if you got problems with the Tram, basically, if you know what these boards do, it's 5 boards and 2 auxiliary boards in this thing. But if you know what they do, you can kind of figure out at least where to start tackling the problem is. Let's start with the receiver board, that big board there. That's the A board, they call it in the Tram books, A board, or the receiver board. And that basically does all your processing and stuff for the receive, right? So if your receive ain't working, but everything else is, it's probably something on the A board. Then down here, well, let's go back to the A board right quick. That little board there, that plugs into the A board, and that's called, and it's part of the A board, but it's called the AA board, the auxiliary A board. So if you're on a schematic or, you know, a book and you see AA, that's what they're talking about, auxiliary A board. And that's part of your receive circuit, and that plugs in. And one of the problems with the heat and everything is that you get cold solder on the bottom of that because of heat. And if you know, get glitches and pops and everything, it may be a tube socket, but it may be the plug on the AA board. But anyway, that's your receiver board, A board, AA board. Down here is your audio board. It's got the audio to your speaker during receive, and it makes the audio to the plate modulator when you transmit. That big tube does that. It needs the audio preamp, you know, tubes there. That one goes to the keying circuit too, but for the most part, it's the audio board, and it's called that in the book, in the schematic. It makes the audio. So if everything else working and you got no receive, no transmit audio, it's probably something on the audio board here, the B board. And also, there's another plug-in board that goes to the audio B board. This one's called the BA board. The B auxiliary board, right? And that's what BA stands for. And this one has some stuff for the that feeds the audio tubes and all that, but it also has the low voltage power supply on it. Provides 14.4 volts that powers the crystal board and the balance modulator board. But that's all this, the audio board, low voltage board right there. I've had some people like, well, Tram was stupid. You know, why did they put the this BA board, which has the low voltage power supply, and then this crystal board, especially over here where the crystal components and stuff are, right up next to the big bad audio tube that's on all the time, that's generating all that heat. Well, basically, the low voltage power supply is very critical because, again, it powers this crystal board, and it needs to be very accurate. And because it's right next to the audio final tube that's generating all that heat, it's like a heat oven. You see, you know, old electronics where they have an oven for the crystals to heat it up to keep it at a nice warm temperature so it's stable. So Tram did that for stability. They got, you know, the critical low voltage board, and then they got the components here, the amplifiers and stuff for the crystal bank, right next to the hot audio tube. So they use that like a heat oven. One thing Tram, I think, didn't expect was for people to, you know, use this radio for 20, 30, 50 years. And, you know, some people leave them on 24/7. I actually put a nice one together for a friend of mine and sold it to him, you know, nice Tram. I think it was a D201A, and he ran it. Well, he didn't run it 24/7. He kept it on 24/7. He gave it back to me a year later. You wouldn't have recognized that radio because of the heat. And I think Tram didn't factor that in. But, you know, they're not the only manufacturer that had that. Tram was not stupid. They came from Browning, and they were part of Browning and Drake Corporation. But anyway, Johnson did the same thing with the Johnson Viking Rangers and all that. They got a resistor in there, in their synthesizer, you know, that makes the channel frequencies, and they call it Chernobyl resistor, because, you know, over time it gets so hot it just burns up the components in there. Again, they call it Chernobyl, as in nuclear. It gets so hot. And again, they used it as a heat oven to heat it up and keep it nice and hot, but they didn't expect people to, you know, use this equipment for 20, 25, 50 years. And, you know, that's what happens over time. So anyway, put a fan on it, but I got distracted. Receiver A board, A board, auxiliary A board, B board, BA board with the low voltage on it. Synthesizer board with all the crystals is the C board. And D, the balance modulator board. That does a lot of your SSB stuff, because it's hard to do SSB with tubes. So it does a lot of the mixing and balancing with your SSB stuff, and that's why it's called a balance modulator board. SSB transmit and receive. So if AM's working and SSB got no transmitters receivers, probably something wrong with that balance modulator board there, the D board. And then last is your E board, which hardly ever fails, because all that is like your SWR, your watt meter board there for the most part, even though it's got your tank coil there on it. And see that big blue thing there? That's an upgraded cap. The cap in this thing is rated for 1,000 volts, which is fine if you're running this radio stock. But if you turn up the mod and or turn up the watts in this thing, which is easy to do, you can run over 1,000 volts of modulated voltage when you modulate. So that cap is short, and then you got all kind of problems. So I say replace that cap with, you know, something over 1,000 volts, 1.5 kilovolts or 2 kilovolts or whatever. I always do that, and that's why you see the blue one. The original is orange. It's an orange drop 1,000 volt in there. But anyway, that's your board. So if you got something wrong, you know, again, SSB not working, It's probably your balance modulator board. Receive not working, but transmit is. It's going to be your receiver board. No audio, that everything seems to be going. It's going to be your B board, your audio board. This board, if you got nothing, no transmit, no audio, no nothing, you could check your crystal board here. And again, it puts out about 20 megahertz. And if you got a scope or a frequency counter, you can connect it right there. Should have about 20 point something megahertz out. You know, a couple volts worth of 20 volts. So I think that's all the talking I'm going to do this time. Just wanted to kind of go through that. There's more, but anyway, I did want to talk about one thing. From the factory, these are modded. Well, not modded. From the factory, you can only transmit on the dial, on the crystals. So you can only transmit 40 channels. And the clarifier won't, it's not hooked to the transmit. And neither is the VFO. The VFO, which you put on manual here, you go to the manual tuning or the VFO. That's hooked for receive only. So if you want to transmit on the VFO, you had to mod this radio. You know, people are like, I run my radio stock. Okay, what do you do for you? I believe you got a nice VFO built in, and it goes to channel 55. From factory, it's set up for receive only, and it takes just 2 or 3 wire changes and cuts here. You can transmit on the VFO, so why not? And then you got, I think it goes like -5 to about 55 on the VFO. And there are other ways to do it too. No, I'm getting long-winded, but when you go to the VFO, it automatically connects to the channel 9 crystal. So it mixes with one of the crystals, channel 9 only, and the frequency of the VFO, and that's how the VFO connects and makes this frequency, and it does that automatically from stock. And you could go up to channel 55. But if you want more channels, there's another way to do it, where it doesn't automatically connect to channel 9 crystal. You can make it so it connects to any of the crystals on the dial. And if you do that, when you go to channel 9, it'll be accurate, right? Because that's the frequency it originally went to. But if you go to 1, you'll be 8 channels behind or under channel 9, so you have more range under on the VFO. And if you go to channel 40, you'll be 31 channels above what reads on the VFO. So if I did this, channel 40, and I'm on channel 55, I'm going to be reading something like channel, 75, 80, whatever the math is. I'm tired, so I'm not doing the math. Used to be good at math, right? So you could do it that way. But if you do it that way, it's only going to be accurate when you're on channel 9. And by the way, I did this one that way. So on channel 9, the VFO manual will be accurate. And it also a transmit on it with the mod I did. And also another mod from the factory, the clarifier is not hooked to transmit either. You can mod it so the clarifier move the transmit up and down too, a couple hertz. And I did that on this one. People like doing that for AM. But if you're an SSB user, you pretty much don't like that if you're going to use a lot of SSB, because what happens is somebody is up or down a little bit, whether it's you or the person you talking to, and they move a little bit to clarify you in, you're going to move a little bit to clarify them in, and since you move your transmit, they're going to move their transmit to match you receiving. So that's going to change them, and then you just keep going. You keep going, you keep going. That's called hunting, because you keep tuning in each other, and you can't kind of keep missing each other as you're doing. That's called hunting. So on SSB, basically, you kind of don't want that mod, but most people on AM, they like to be able to move the transmit a little bit. But anyway, this one is very clean. It's a customer's, not mine. I took it on because it's clean. It's got low miles on it, and I had some time, so we finished this one, recapped it. tuned it, went through it, and this one's a screamer. I think I got it hooked to the dummy load. Let's go to channel. Well, it don't matter. I'm on a dummy load anyway, right? We're on a meter. Let's put it on average, and hopefully we ain't knocked nothing off. And I only did keying about 1.5 watts. But I'm on average, right? And look, hello, 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 hello. I'm talking about 8 from 1.5 watts. Whistling to 10 on average. That is a lot of swing for a tube radio. Like I say, Tram audio on the 1 to 10's a 12, and this one might be a 15. This is a talker, and then we got it on peak. Audio, 1.5 dead key. Audio, I'm probably doing about 25 watts on peak from 1.5. I'm gonna do one more thing. Speaking of watts, right quick, let me turn it off. And the radio won't kill you anyway if you stick your fingers in there, but it'll sure make you talk like a chicken or duck like a chicken. Anyway, these two resistors here are the power dropping resistors for the final. Going into the plate modulator, these take the voltage down from about 400 to about 225, I think. So they drop the voltage going into your audio final. Well, not your audio, I'm sorry, RF final. And if you want to boost the watts on the Tram, these are the two that you hook the switch to bypass them. To take them out of circuit, bypass them, is these two big resistors here. And if you bypass them both, you did key about 8-10 watts. But when you do that, the more you did key, the less audio and the less swing you have. So you lose a lot of audio when you do that. But anyway, more watts, you want to run a switch and some wires off those caps to do that if you want more watts on the Tram. And I think that's about all I wanted to go through today. But here's a Customers D201A, a nice one. And again, I'm not taking on any more work. I got too much of my own. I only took this one because it's low miles and clean, and I knew the guy, so I took that one on. So that's gonna be it of this very nice Tram D201A before I send it back. Bye.